Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Student, this is the last question, that is question number 45 of NEET Physics paper 2015. Student, the question is, a potentiometer wire has length 4 meter. If I have, suppose this is the setup, this is the EMF of the accumulator, this is called accumulator EMF or the driving cell, and we have a potentiometer wire which is connected here. This is the potentiometer. Suppose this point is A, this point is B, then this length LAB, this length of the wire is called potentiometer wire, whose length is 4 meter. So this is 4 meter. The resistance is 8 ohm. So the resistance of this wire AB, RAB, I write as 8 ohm. The resistance that must be connected in series with the wire. With the wire, some resistance is connected in series with this wire. So you can connect here, 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 anywhere, but it should be in series. Suppose I connect a resistance, say X. The resistance that must be connected in series with the wire and an accumulator of EMF 2 volts, this accumulator is 2 volt. So as to get the potential gradient 1 millivolt per centimeter. So the potential gradient, suppose K, is 1 millivolt per centimeter on the wire. So this is what is the potential gradient required across the wire. So at any point and between any 2 points, this is the potential gradient. The potential gradient required across the any 2 points. Suppose I take this point or I take this and that point, this is a constant quantity. This will not change. However, large or small the length may be, the increase in potential drop will also increase the length. So these two increases proportionally is the volt, the potential difference between any 2 points, and the length between those 2 points varies directly. This is the principle of potentiometer. Therefore, I consider K is constant is, and we are supposed to find X, because as we change X, this K, the potential drop will also change. If I increase this, this will decrease, because the potential drop across the potentiometer wire will be lesser. So if that is less, then potential gradient will also decrease. So now the question becomes very simple. We have to apply that potentiometer principle, that the potential drop is same, and we have to develop this K. So for that we have to see how much current. First we have to find how much current is flowing in this circuit. This wire is having a resistance of 8 ohm. The resistance I have connected in series is X ohm. The total resistance in the circuit is 8 plus X, and the accumulator has EMF 2 volt. So by simple law, Ohm's law, you can apply Kirchhoff's voltage law, you can apply Ohm's law. This is a very simple circuit. So I apply Ohm's law, that the current, the main current in the circuit is the EMF that is applied, that is 2 volt, divided by the total resistance, that is 8 plus X. Because X is also unknown and I is also unknown, therefore I have to look for another equation. Okay, what is that equation? I have to write what is given is the potential gradient. This is given. The potential gradient K, I suppose, is given as 1 millivolt per centimeter. That I'd write in SI system, this is 10 raised to the power minus 3 volt per centimeter is minus 2 meter. So this is 10 raised to power minus 1 volt per meter. So for every 1 meter, there is a drop of 0.1 volt. The formula for this, I would write that this K is basically the voltage drop across the wire, the potential drop across the potentiometer wire, because this is proportional, the ratio is always constant. The potential drop across the wire AB to the length of the wire AB must remain constant. This is given as this one. The voltage drop AB across AB is the current flowing through this and the resistance. The current is this one, because whatever is the current, that current also will flow through this potentiometer wire. This is the current. I'll write current and resistance RAB divided by LAB. What is the current? The current is 2 divided by X, 8 plus X. 2 divided by 8 plus X is the current into resistance, which is given as 8 ohm. So I multiply 8 divided by the length of the potentiometer wire, which is equal to 4. So K is this one. I can also write that 4 to the 8 here, so it is 4. So this is 4 divided by 8 plus X. So from here I write K is equal to 4 divided by 8 plus X. If I cross multiply, I have to write the value of K here, which I got as 10 to the power minus 1 volt per meter. You can see here the value of K is 10 to the power minus 1 volt per meter. If I substitute that, which is 1 over 10 volt per meter, if I substitute here, 1 over 10 equals to 4 divided by 8 plus X. Cross multiply, 8 plus X is 40, X is 40 minus 8, which is 32, and X is what? X is the resistance that I have connected here, and that comes out to be 32 ohms. So this is 32 ohms. If you see the options, the option number 3 is the correct option to this question. Okay, thank you.